Okay, so yesterday we talked about arc length, yeah. And I give you an arc from some A to B. We can find out how long that arc is, right? And that formula was kind of messy at times, right? Sometimes it gives you a really nasty integral that you have to use a calculator on. Right. So the question of the day is, how can I use that to calculate surface area? Right? And it's very similar to a volume of revolution. In a volume of revolution, we revolve this around an axis, and we end up with circle area, so our formula involves pi r squared, right? Well, we have a very similar thing here, wherein we're just calculating surface area now, or sorry, surface area. So we need the circumference of the circle this time, right? The question is, what's R? Yeah, that's exactly what it is. It's f of x. Right. And then we will multiply by the length of the arc. That's our formula. Okay. So we have surface area. What does your book call it? I have a letter for it. Wow, imagine that. Big S. 2 pi integral from a to b, and the radius is f of x. Right. That will give you one circle circumference. Now we just need to multiply by the length of the arc to get the entire shape. Okay. And there's your integral. And it can be even nastier than arc length, because you've got this extra function in here. Right? Most of the problems we see on the AP exam for this concept are write the integral but do not evaluate it. Okay? Because it's just a calculator punch most of the time.
So your radius is just the integral of f of x added integral function from last time?
Yeah, so this is your basically the length of your surface. This is the radius. So you have the circle circumference here times how long that line is. It gives you, the surface area. Much like volume of revolution, it's pi times f of x squared. Your radius is f of x. Same concept. You just have this arc length messiness. Yeah. Okay. Let's see. Woo, that looks fun. Let's do it. Calculate.
So this doesn't seem like super complex, it's just a lot of work.
Yeah, it's no different than volume of revolution or any of that nature. It's just, there's just a lot more junk. Yeah, nasty intervals. Calculate the surface area of the surface obtained by rotating the graph of, this is going to give us fits. Fun. Oh, let's make that 1/2, since we're using the book example. Minus about the x-axis. Four, 1, 3. Woo. Notice it's about the x-axis. Okay. I don't ever remember seeing it different than that, but if it is, you just subtract out that rotation line, just like volumes of revolution. So, again, I always write the formula out for memorization purposes.
Wait, could you even do, I mean, if you rotated it about like another thing other than the x-axis, wouldn't it still do the same?
Well, what you would have is this function minus, let's say you're rotating it around -2. Your radius would become this function minus -2. Do you need me to draw that out?
Maybe.
Okay, so let's say this is your function. When you're rotating your shape around the x-axis, your radius is just the function, right? But if we change the rotation axis, the radius becomes the function. Let's say this is -2 minus -2. So you just add 2 units to that radius, just like volumes of revolution. All right, so here we need f prime of x, right? So what's the derivative of that? Yuck. All right, I'm going to rewrite that. 2 root x minus x over 2. And now we can write our integral. Let's square it first. I find it easier to square here. Over 4x. That does actually work out quite nicely. Minus 1/2. And then plus x over 4. So I just FOILed the two of those together. Alright, you good with that? It's just kind of nasty. Okay. Plug it in, plug it in. Alright, what's f of x? The root 1 minus, so when you subtract this whole thing, remember that's going to turn some things negative, so negative 1 over 4x, come on computer, keep up, and then 1 minus negative 1/2 is 3/2, and negative x over 4 dx. We squared it here. Is it plus? Did I goof it up? Huh? Oops, I did. Okay, chalk one up to let's rewrite. Thank you for pointing that out, because it's probably going to make things a little easier. All right, so 1 plus negative 1/2 is only 1/2. And 1 plus x over 4. Okay. So there's your integral. Yeah. That's doable. I'm sure it is. Yeah. Okay, so I think your book goes through and gets a common denominator here, and it becomes a perfect square of some kind. Let's see, just for the sake of mathematical fun. Come on, computer, keep up. Okay. The common denominator is going to be 4x, right? So I'll have 1 here. If I put 2 times x here, so plus 2x, and this needs an x, so x squared. Yep. That's a perfect square, isn't it?
The same square, actually, like the derivative of y squared. Look at that on my paper. Pretty much you take the derivative of y
Yeah.
and you change the minus sign to plus sign.
Yep.
That's
That's about how these will usually work out. That's what the book does. Different route here. Okay. Let's just see here. So this becomes x plus 1 squared over 4x. So we end up on these extended page of problems. You just got a lot of algebra to do to make this more simple. This should be x plus 1 over 2 root x, right? We can put this, this can go into each term. So x divided by 2 root x x to the 1/2 over 2 plus x to the negative 1/2 over 2. Okay, you FOIL those together. And you get a very doable integral, right? You good with how I got all this stuff? A lot of heavy algebra.
Where did the 1/2
Here? Okay, this is x to the 1/2, right? So if we have x to the first over x to the 1/2, we subtract those exponents, right? So 1 minus 1/2 And then this is x to the 0, 0 minus 1/2, or you just move it up top. There you go. Yeah. Yep. And then when you FOIL, you're just going to have these multiplied. You add the exponents, and you end up with a polynomial integral. Okay. Oop, that should be a 3. My 3 slowly lost their tail. Okay. Are we good? Again, sometimes you write it, you don't evaluate it, sometimes you do. If you can do it by hand, please do. If not, there's a calculator. Use it. Did I write down all the homework yesterday?
Yeah.
Yes.
So you got, yeah, I think I did. Okay. You got about 10 minutes if you have any questions. I'm here. Yeah.
That makes life a whole lot easier because yesterday me and Wyatt were trying to solve some of these problems and I was like, I can't.
Yeah, I didn't mention that I gave you all of the work for both days.
I was like, I can't do it.
On computer, keep up, man. Come on. You know you ought to do it.
It's not.
It's like, I don't want to shut off. I want to continue recording your stupid comment. Fine.